Hello everyone. Should we start? Nishant Muhammad Abdul. Okay. Yes. So it's the time to proceed. Okay. Here is my brief introduction. As you people already know, I'm Jyoti Sharma and I'm a PhD student from ISER Bhopal. And I had my MSc in Environment Management from Forest Research Institute, Dehradun, and BSc in Botany Honors from Delhi University. And because I'm a PMRF scholar, so that's why I have the responsibility to teach, and I opted for this NPTEL to teach. So let's start with the strategy, how we will proceed. So I have lots of MCQ question, and we will try to find out the answer of that MCQs with some kind of discussion. And you are encouraged to speak, either speak or write in the chat box or communicate as much as possible, so that you can grasp whatever we are talking about, right? Then Today we will talk about how we can control the air pollution. So there are some techniques and there are some devices as well. Based on some techniques, we will know what kind of mechanism we have by which we can control this air pollution, and by exploiting that techniques or the mechanism, we have some controlling devices. So we will talk about how we can control the particulate matter and how we can control the gaseous pollutant. Okay, so here there will be the brief introduction about this air pollution control, and then these four parts are based on like different mechanism and the controlling device for the particulate matter, and secondly for the gaseous pollutant. So these four lectures are like that only. These are the previous assignment questions initially. Then I have my own questions that I will discuss with you. So these are first 10 assignment questions that I have taken from the last year. So let's start with it. So the first question is, identify the air pollution control device which is not employed for the reduction of particulate from stationary sources. So I have four options. The first is three-way catalytic converter, the second is settling chamber, the third is inertial separator, and the fourth is cyclone. Uh, I think Nishan gave me already the answer A. Abdul, are you here? Do you want to communicate?
Yes, ma'am. I hear, ma'am.
Okay, hi Abdul. Can you see that question and can you try to give the answer of this if you know and even if you don't know?
I will try, ma'am.
Yes. So what do you think? What should be the answer of that?
Uh, I think cyclones.
Okay, actually the answer is three-way catalytic converter. We will talk about this, how this is the three-way catalytic converter. Actually, the settling chamber is a kind of chamber in which the gas with the particulate matter will come in and will go out. And while that gas will go out, it will be cleaner in nature. So this is for the reduction of particulate matter from stationary source. Then the inertial separator. This is again the thing like that. Uh, we have some fibers, for example, and we have like some obstacle. And when the gas will come, this gas will stack to the obstacle. The gas will change the direction, but the particulate matter can't. Because of that, particulate matter will settle down. Then the cyclone, we will talk about the cyclone as well. These three are the devices by which we can reduce the particulate matter from the stationary sources. But the three-way catalytic converter is one that we use in the vehicles. For example, in the vehicle, there is some unburnt combustion is there, or the partial combustion. If whenever there, then because of that there may be some gases, for example hydrocarbons or ammonia. Such kind of gases can be released into the atmosphere. So for that, to complete the combustion, we use some catalyst. Okay, and because of that, we reduce the gas of the toxic nature from the vehicles to release. Okay, so the three-way catalytic converter is not for the stationary source but for the mobile source. For example, for the vehicles, but the rest three are for the stationary source. So Nishan gave me right answer, and this should be A. Okay, the second question is, which of the following method is used to control emission of pollutant from crop residue burning? So if you want to reduce the pollution from crop residue burning, what the option you have? Uh, there are four options that I gave you: the wind barrier, the maintaining soil surface cover, the spray tower, and the happy seeder. Nishant already gave me the answer. Abdul, will you try for this question?
I also think it's D answer.
Okay, exactly. Answer is D. And whenever we want to control the particulate matter, right? Particulate matter from the agricultural area, then this wind barrier is one of the option. Secondly, maintaining soil surface cover is also when there is like particulate matter that are emerging from the agricultural area. Spray tower is different thing, and the happy seeder is one where whenever there is a stubble, and to avoid that stubble burning, what we do, we just with the help of the machine, we extract that stubble and we can use it to sow it in another farm. Okay, so this is kind of the device that we use to avoid this stubble burning. So answer should be D exactly. That is the happy seeder. Okay, then identify the type of removal mechanism that has been shown in the figure to remove particles from the gas stream. So I have four options, that is the Brownian diffusion, inertial deposition, electrostatic attraction, and the gravitational setting. So from that picture, what you are grasping? What it is? Nishant already gave me some answer. Okay, he gave me A answer. That is the Brownian diffusion. Yes, so answer should be A only. Why? Why this is? You can see whenever there is something that can be act as a barrier. Okay, for example, you have cloth. Okay, and whenever the gas with the particulate matter will strike to it, the gas will change the direction, but the particulate matter can't change the direction, and because of that, it will strike to the barrier. This is the first thing. The second thing is, the movement of the particle is always a zigzag movement. Okay, and this zigzag movement is nothing but the Brownian diffusion. And this is also the mechanism that we exploit to control the particulate matter from our gases. Okay, so this is the Brownian diffusion. Okay, the next question is related to the settling chamber. We will talk about this again because from the start, I will start from the first lecture and then we will slowly build up. What do you mean by this settling chamber? What do you mean by this stock velocity? What do you mean by different kind of mechanism and the velocity? These are just, I'm just finishing initially previous year question first. Otherwise, we will start from the scratch, right? Okay, so here I have four statements related to the settling chamber, and you have to tell me which statement is right. Uh, so this statement is solids move along the chamber with stock velocity and settle with the velocity of the gas. The second option is solids move along the chamber with the velocity of the gas and settle with Stokes velocity. Third option is solids move along the chamber with the velocity of the gas but do not settle with stock velocity. And fourth is solid move along the chamber with stock velocity but do not settle with the velocity of the gas. Uh, so this is related to that only. Whenever you have some chamber, in that chamber there is a like gas with the particulate matter is coming in. Okay, so to settle the particulate matter in that chamber, what should be the velocity of your gas? What should be the velocity of your particulate matter? So this is all about that only. Nishant gave me some answer. Nishant gave me B answer. Abdul, do you want to try for this question? Okay. I get B answer from rest of you too. Yes, the answer is B, and we will talk about this. As I already told you, there is a chamber, and in that chamber, whenever the gas is coming with the particulate matter, this particulate matter will settle down. Okay, so to settle down, there should be the velocity, and that velocity will be based on the Stokes law. Okay, and you already may or may not be Stokes law, but we will talk about this. Okay, there is a some kind of ratio, and that ratio is defined as actual gas flow rate at maximum operating condition divided by the total fabric area in the baghouse. So you have to tell me what kind of ratio we are talking about. So we have four options: the net cloth to air ratio, gross cloth to air ratio, then net air to cloth ratio, and gross air to cloth ratio. Okay, Nishant gave me B. Answer D. Alka C or D maybe. You're right, Alka. You can little push up yourself and you can tell the right answer. Of course, it will be from C and D only. Mohammed gave me answer B. No, this is not B because if it is a ratio of gas flow rate divided by the total fabric area means you are talking about the cloth, and that cloth will be next. And before that, we are talking about the gas flow rate, means we are talking about air. So, firstly, there should be air, then, secondly, there should be the cloth. Okay, so the ratio should be air to cloth. This is very clear from the definition itself, but you have to tell me whether it is gross or net. So, this is the example of the fabric filter that we use to control the particulate matter. So, for example, you have some fabric, and this fabric is just to control the particulate matter. And whenever you have only one unit of that fabric, then this will be the gross air to cloth ratio. But when you have the multiple unit of this fabric filter, and maybe some are in use and some are not, okay, so then this will be the net air to cloth ratio. Okay, and it is very important to calculate how much flow rate you are having and how much surface area of your cloth that will be used as a filter is. Okay, so of course the answer should be D only, that is gross air to cloth ratio. Okay, so here I have the name of the device you have to tell me, and in that device, gas ionization and particulate collections are combined in a single step. So two-stage precipitator, single-stage precipitator, fabric filter, and wet scrubber. Nishant gave me answer B, single stage. Alka, do you want to try for this question? Okay, B. Of course, answer is B. How? The first, yes, Mohammed, it is B only. Why it is B? Initially neglect C and D because we are talking about the gas ionization. Okay, so whenever we are having the high voltage difference, and because of that, we are transforming our gas into the ions, then the technique is the precipitator only. Okay, so C and D are not among the right answer. Then we have A and B because we want to combine into a single step, so there should be only one stage or the single stage precipitator. So of course answer should be B only. Okay, so this question is adsorption, not absorption. Adsorption process is classified as either physical or chemical. The type of force involved in physical adsorption is a chemical interaction, van der Waals force, centrifugal force, and no forces involved. Mm, Abdul told me that it can be B or C. Okay. Yes, you are right. You have to select among B and C only. Nishant gave me answer B. Okay, so yes. Alka, will you try or I should go further? B or C, no idea. Okay, so the answer is B only. That is the van der Waals force. Because we are talking about the adsorption, and adsorption are nothing, but you have some surface. Okay, and on that surface, on the top of that surface, your particulate matter will be adsorbed. Okay, will combine it with combine to it. Okay, and this combination may be because of the physical process or maybe because of the chemical process. If it is a chemical process, means the molecule of your adsorbent will have some kind of chemical interaction with your particulate matter or with your gaseous pollutant. Okay, so this is the chemical process, but in the physical process, there is some kind of electrostatic force, and this is very mild in nature. This is very weak, and because of that electrostatic force, your particulate matter or gas can attach to the surface. Okay, and the weak electrostatic force is nothing but the van der Waals force. Okay, so and centrifugal force is kind of different thing. So for the adsorption, the van der Waals force is the right answer. So answer should be B. Okay, the gaseous contaminant being absorbed must be at least slightly soluble in the scrubbing liquid, which is termed as. So in previous question, we talked about the adsorption. So adsorption is nothing but like on that surface, there is some like attachment will happen with the pollutant. But this case is for the absorbent or for the absorption, and in which there should be some liquid, and in that liquid, your gaseous pollutant will be dissolved. Okay, so the this question is related to the terminology that you have to tell what kind of liquid we are talking about in which your gas will be dissolved. Okay, so Nishant gave me answer A and Alka A maybe. Abdul also gave me A. Okay, so you three people gave me answer A, then sure, yes, it should be A only. So there is a like terminology because we are talking about the liquid, and in that liquid, your air will be dissolved. Okay, and this liquid is known as the absorbent because it will absorb your gaseous contaminants. Okay, so answer should be A. Okay, the next controlling device is or the technology is oxidizer, and oxidizer can be used to destroy a variety of what type of things you can destroy with the oxidizer in the effluent gas stream. So metallic compound, organic compound, inorganic compound, or the particulate matter. Everyone gave me B answer, then yes, of course, it is a B. And the mechanism is like that. You have the organic compound, means most of the time it is the hydrocarbons, hydrogen plus carbon compounds. And whenever there is a oxygen, because we are using the oxidizer, so whenever we are giving them the oxygen in the presence of some high temperature, then this organic compound will be converted into carbon dioxide and water. Okay, so this is the work of the oxidizer, and in which we, yes, we do oxidize the organic compounds. So answer should be B only. Okay, I think this is the last question of the previous year. Which of the following technique is adopted when the contaminant concentration is high enough to make a recovery feasible and economical? So, biofiltration, oxidation, condensation, absorption. Nishandan Arka gave me C answer. Okay, Abdul also gave me C answer. Yes, the answer is C only, and here the mechanism is that because your gas have some hydrocarbons or the organic compounds, and it may be that that organic compound are very valuable and maybe expensive, so you don't want to lose it. So what you will do, you will reduce the temperature of your that gas by somehow, because of, there may be refrigerator system, there may be cryogenic system. So because of that you will reduce the temperature, and because of that the gas will not go out, okay, from the vent, and that's how you can save your organic compound that are interested to you and that may be expensive. So yes, and this process is nothing but the condensation. So answer should be C only. Okay, so these were the question of the previous year, but right now we will start with the scratch and we will try to understand each and every concept based on the MCQs. So here is the introduction to the air pollution control. Uh, okay, so we people know that we have some natural self-cleansing property of the atmosphere. Okay, and we exploited such self-cleansing property to develop the controlling device. So you have to tell me what kind of mechanism we are talking about that are self-cleansing property of the environment. So I have option dispersion, gravitational settling, the combustion, absorption, rain out, and the adsorption. So you have to tell me the self-cleansing property of the environment. Alka gave me answer D. You have to think a little bit focused. So, for example, I just give you one example. Whenever there is a chimney, and from that chimney, the pollution is coming out. But after some time, this pollution cannot be at the same concentration at that particular time. So, what happened to that kind of pollution? How your environment is still clean after so much pollution from your chimney? So what kind of self mechanism we are talking about? Alka, your answer was little bit closer. Yes. Okay, so answer should be C, because combustion is not the self-cleansing property. Environment doesn't intentionally do this combustion, but accept this combustion dispersion. For example, like whenever the chimney is there, because of the atmosphere, because of the wind direction, your concentration of that will be diluted. Okay, so this is kind of dispersion, and because of that dispersion, uh, your environment will be cleaner. The second is gravitational settling. You people know that most of the time, whenever there is a storm, then there is a high level of particulate matter into your atmosphere. But after some time, because of the gravitational settling, that particulate matter can settle down. Okay, so this is the gravitational settling. Then I told you combustion is not the right answer. Then the absorption rain out. So this is like whenever you are having the rain, and because rain will cross your atmosphere vertical profile. Okay, so in your atmosphere you have the particulate matter. So what will happen? This particulate matter or gas will be absorbed by your rain droplet, and because of that it will again go down on the surface. So this is the absorption drain out. Then the adsorption. So for example, you have like you have like for example aerosol, some aerosol, and some other chemicals can be attached to that aerosol, and because of the flocculation or because of being heavier it again can settle down. So this is the adsorption. So answer should be C. And based on based on these self cleansing properties, we have the we have some controlling devices as well. For example, we for example, for the gravitational settling we have the gravitational settling. There is a one device. Can you give me the name of that settling chamber? So we do use the settling chamber to just copy the gravitational settling mechanism of the atmosphere. Okay, so I have question related to each of these properties. So, but the right now the answer is C only. Okay, so here the question is about the dispersion. So you have to tell me the characteristics feature of the dispersion. So the driving force is wind, the driving force is the gravity, it is the dilution of the air pollutants. It does remove the pollutant from the environment. It does not remove pollutant from the environment, but helps in its transportation and transformation. So you have to tell me the right statement. Take your time. So right now we are talking about the cleansing properties, and because we talked about whatever mechanism we have to clean the environment, so one of that cleansing mechanism is the dispersion. So you must know about the dispersion. What do you mean by that dispersion? What's the characteristic feature of that dispersion? Can you guess the answer? Alka, Nishant, Abdul. I got to know that repeated questions, you had the answer for that repeated questions, but right now the question has been made by me. So that's why you are taking time now. Nishan gave me all of the above, at Alka is 1 and 5th. 1 and 5th. A and D. Okay, so the first thing is that for the dispersion, like to dilute the pollution. Okay, so the driving force is wind. Okay, so in the horizontal direction, for example, there is a chimney, the wind will come, and because of that wind, there will be the dilution of air pollution. Okay, so this is the phenomena done by the wind, but not by the gravity. Okay, so second is not among the option. So you can neglect the driving force is the gravity. You can neglect that one. Then what else? Can you guess now? If second is not the right answer, the driving force is just the wind, not the gravity. Option D. Yes. Yes, option is D because I told you the driving force is not the gravity but the wind, the first thing. The second thing is the dilution of the air pollutant. For example, initially it was it was in like the same pollution was in let's say in 1 centimeter cube, and because of the wind, that that pollutant can be dispersed out in the thousands of the kilometer square area. Okay, so this is nothing but the dilution, because at each portion of your atmosphere, now the concentration of your pollutant is lesser. Okay, so yes, this is the dilution of the air pollutant. Though, so the first and third should be right. Then it does remove the pollutant from the environment? No, it doesn't. It is just diluting it. Okay, and but yes, the fifth option is right. It doesn't remove pollutant from the environment, but it helps in its transportation and the transformation. Because it will because of that, it will your pollutant will go from point A to point B, and while going A to B, there will be transportation, no doubt, and there may be some chemical reaction with the with your atmosphere whenever it is moving. So this is, there may be some kind of transformation itself. So yes, your first, then third, and then fifth should be the right, and based on that, D is the correct option. So this was all about the dispersion. And here we can see the dispersion of pollutant by wind reduce the concentration of air pollutant at the place by diluting them. And it doesn't remove the pollutant from the environment, but helps in its transportation and transformation. Okay, the next question is about the gravitational settling. This is the another self-cleansing property of the atmosphere or the environment. So this settling is effective for the particles that are larger than what size? So you have to tell me the size for which this is very effective. Alka gave me answer C. Abdul Nishant, would you try? A. Uh, you have to keep in mind that larger the size of our particulate matter we have, it is easy to settle down. Okay, because of the gravitational. Whenever there is a very smaller size, then it will be difficult to settle it down. No, exactly. Because we are talking about the effective, then answer is not D, but it is C. That is 20. No doubt, the gravitation, the gravity is. Can you tell me the formula of the gravitational force? Gravitational force is dependent on the mass, and even the even your radius. And whenever we are talking about the gravitational settling, then no doubt, larger the area or larger the radius of your particulate matter, it will be easier to settle down. Okay, and because we are talking about the effective, so this is 20. No doubt, 30 micrometer is easily to be settled down, but 20, like the efficiency with which it can settle down is the size is 20 micrometer. Okay, so here we can see, based on that, we have the settling chamber. We exploited this self-cleansing property and we developed the settling chamber. And this is nothing. We have the dusty air, and because of your the gravity, that particulate matter will settle down and your clean air will move out of it. So this is the most important natural mechanism under which heavy particles from the ambient air settle down. So gravitational force is, you people know that it is dependent on the mass. Then this process also help in removing the flocculated particles formed by uniting smaller particle over larger particles. So whenever you have the smaller particle, that will conglomerate, that will form a bigger particle, and whenever it has been formed into the bigger particle, then it is easier to settle down, and it is effective for the particles that are larger than 20 micrometer in size. Okay, then the third cleansing property was the absorption. So I have question for this absorption. So you have to tell me the characteristics feature of that absorption. So I have three options. Both gases and particulate pollutants can be removed from the atmosphere. It removes particles smaller than 1 micrometer in size, and the C is gaseous pollutant are removed in the dissolved state with moisture, either with or without chemical changes. So you have to tell me the right option. Can you tell me the right statement about the absorption? Um, C. Nishant, what's your answer? What do you think? Okay, I think Alka and Abdul gave me right answer. This is C because absorption can remove the particles that are larger than 1 micrometer in size. Of course, this is kind of the thing that you have to learn, but like this is not the technical thing. But yes, because of C, you gave me a wrong answer. And this is all about the absorption. So yes, with the help of absorption, we not only can remove the gaseous or the gaseous pollutant, but also the particulate pollutant. So this mechanism is for both the things, the gaseous and the particulate matters. Then it takes place below the cloud level. So for example, there is the cloud, then absorption will happen in below the cloud, because whenever there is a rain, that rain will do, because rain have the water, and this water will absorb some kind of particulate matter or the gaseous substances. Okay, so this will happen below your cloud level. Then it doesn't help in removing particles smaller than 1 micrometer in size, and then gaseous pollutant are removed in the dissolved state with moisture, either with or without the chemical changes. Okay, there is one question. The chemical that we use for the cloud seeding, have you heard about that cloud seeding? What do you mean by this? Well, whenever there is a high level of the particulate matter into your atmosphere, so what you people do, because of because the visibility is so low, or maybe the particulate level is that much high, so with the help of airplanes, with the help of the drones, we just seed some aerosol into our atmosphere. Because of that aerosol, that will help in the condensation process and the cloud formation. And whenever there will be the artificial rain, so cloud seeding is nothing but helping in the artificial rain. So whenever there will be the artificial rain, then particulate matter that has been backed this cloud will go down because of the absorption. So you have to tell me what kind of chemical we do spray so that cloud can be formed into the atmosphere and there may be the artificial rainfall. Can you guess the chemical name? I have four options: iron iodide, silver iodide, potassium iodide, magnesium iodide. Abdul gave me D answer. No, this is not D. Okay, give me answer B. Yes, it is B. So we people, yes, Rashmi also gave me right answer. So B is the right answer. We do use the silver iodide spray. Okay, we have the spray of silver iodide in the atmosphere with the help of helicopters or trains. Because of that, whenever there is a silver iodide, this will act as the aerosol or the condensation nuclei around to which there will be the condensation of water, and because of that there will be the rainfall whenever, and this rainfall can reduce the visibility problem, can reduce the particulate matter that you have into your atmosphere, and that is giving you the hazardous impact. Okay, so this is all about the artificial rain that we were talking about, I think in January and February for the Delhi, and IIT Kanpur also tried to make it happen, but I don't know, somehow it doesn't, because naturally rainfall was there only. Because of that, we avoided that artificial. So yes, the answer is B. And here we can see, like the first is the aircraft inject silver iodide or other substance in the atmosphere, and these chemicals will meet the particle that serve as the surface for the condensation. Okay, and that will create the water droplet, and after that condensation, there will be the rainfall. And this is nothing but the cloud seeding or the artificial rain. This is just the second illustration of the of this seed. Okay, the self-cleansing property of atmosphere is rain out. So rain out is nothing. Talked about that absorption. So absorption was beneath the cloud you had the particulate matter. Okay, but in the rain out, the near to your cloud there is the aerosol or the particulate matter itself. Okay, so it is not the beneath the cloud. So what will happen, that aerosol, that particulate matter will act as the condensation nuclei and will go down with the rainfall. Okay, and this is the rain out strategy. Then the next is adsorption. So we people know that uh, there was some question about that also. So whenever we have some particulate matter or the liquid or the gaseous pollutant into your atmosphere, there is some kind of attraction that may be electrostatic, for example, that van der Waals force, and uh, because of that, your some substance may have this particulate matter that can be attached to it. Okay, and this is again the self-cleansing property of the atmosphere. So we talked about the self-cleansing property. So first it was adsorption, it was absorption, it was rain out, it was the gravitational settling, it was the uh, that's all. I think we talked about this. So based on that, we developed some controlling device because we built that mechanism into our device so that we can avoid this kind of condition. So can you match the right hand side? At the one side we have the self cleansing property, and at another side we have the device that we developed based on the self cleansing properties. Nishan gave me answer C. Okay. What do you think? C. Do you want to try? Nishan, Rashmi also gave me answer C. Okay, yes, the answer is C. Uh, okay, everyone gave me the right answer. If it is the absorptions, then absorption means you have some liquid, and in that liquid you will dissolve some. Okay, dissolve it matter. So for the dissolving, there must be the liquid absorbent, and the liquid absorbent is in the spray towers, and even in the plate towers. Okay, if we are talking the adsorption, means you have some surface, on that surface your pollutant will be attached. Okay, so we can use the activated carbon, we can use the silica gel as a surface on which our pollutant can be attached. So for this absorption, then rain out. So for that rain out, we have the wet scrubbers. We will talk about this. And for the gravitational settling, again, we talked about this settling chamber, and we will talk about the cyclone as well. So these are the controlling devices that we developed based on the self-cleansing property of the atmosphere or the environment. So, which is the best way to control the air pollution? What kind of strategy we must adapt? Reduce the emission source, reduce the emission discharge, dilution of the source discharge, and the dispersion of source location. What is the best mechanism? Rashmi, your initial answer was right. See, I gave you one example. Initially, we had the buses based on the diesels, okay, in Delhi. But, and because of that, the sulfur, SOx and NOx concentration was so high in Delhi. So, and to remove that SOx and NOx is a different thing. But just to remove that source itself, like we can remove that diesel, we can use the CNG buses, and because of that CNG buses, that SOx and NOx is not at all the problem. So why do we need to control that SOx and NOx if we can control the source itself? Diesel, avoid the diesel, avoid the fossil fuel. We can use the like non-conventional sources, for example wind energy, for example solar energy. Why do we need to use that fossil fuel? Because whenever we will use that fossil fuel, what will happen, it will obviously will generate something, and we have to control that, and it may or may not possible to control everything. Okay, so it will be better if we reduce the source, emission source itself. Answer should be A only. Okay, I think you got my point. Like instead of diesel, we can use the CNG. Okay, and what we can do? This is the just replacement. The first thing is replacement. The second is we can do some modification itself. For example, you have the ore, the iron. Sorry, you have some fossil fuel, and in that fossil fuel, you have the sulfur content. You people know that you have some sulfur ore in your fossil fuel. So what you can do, you can remove sulfur initially before using your fossil fuel. So this is kind of the modification you can do. Okay, you can clean your fossil fuel in such a way that it will not the pollution will not be happen because of that. Okay, so this is kind of modification. You can do the replacement even, and the third is you can reduce it. For example, you were using the 1 liter of CNG or the diesel, you can avoid that. You can use, let's say, 200 ml only. Okay, so there are some ways by which we can reduce the emission source, and this is the best way, because whenever it has been released into the atmosphere, then it is not that much easy to control it, right? And this dilution, this dispersion, and the reduce of discharge, this is not that much easier. Of course, reduce at the source itself is not very easy task because of the uh, uh, because of the economy. For example, we are using the fossil fuel. Why we are not using the solar energy? Why we are not using the wind energy? Because we know that fossil fuel are so cheap to generate, right? So of course there are some challenges, but the best way how we can control the air pollution is the reduce the emission source itself. Okay, so which method is not used for control of emission from mobile sources? So we have some techniques, and some techniques are for the stationary sources, some techniques are for the mobile sources, some technology are for the particulate matter at the stationary sources. So this question is based on how we can remove the emission from the mobile sources. So you have to tell me. So I gave you some ways. Okay, just keep in mind that I use the word not. Okay, you corrected yourself. Okay, Nishant gave me answer D. So to control the emission from the mobile sources, what are the techniques that we use? This question is all about that only. Then yes, Nishantan gave me right answer. That is D. Because we do use EGR, that is the exhaust gas recirculation system. We do use the air injection system, and yes, we do use the evaporative control system. So what do you mean by this? I have two or three slides for this. Answer should be D only, because these all are the all are the mechanism by which we can control the emission. Uh, and these are all methods. So in spite of that EGR, air injection, and that evaporative controlling system, we do have two another, that is catalytic converter as well as the positive crankcase ventilation valve. Okay, so we have like we have more than these, but these are most popular method by which we can remove the emission from the mobile sources. So mobile sources means from the vehicle mostly. Then if it is the exhaust gas recirculation system, so this is nothing but like this, from the engine you are getting some unburnt hydrocarbon, for example, or the combustion is not completed. Okay, so because of that there may be SOx, there may be NOx, and there may be like some unburnt hydrocarbons. Okay, and because we want to convert this hydrocarbon only into hydro water and the carbon dioxide, but engine gave you the unburnt hydrocarbon. So what you will do, that unburnt hydrocarbons, or that air that has been released from the engine, will be given back to the engine. Okay, so this is the recirculation. And because of that, because you are giving that gas again to the engine, that will reduce the temperature. Whenever there is the temperature reduction, then because of that the NOx concentration will be slow down. Okay, and by which we can like cleaner gas can be released from your automobile. So this is the exhaust gas recirculation system. The second was the air system. So in that air system, what we do, to complete the combustion, the excess of air is injected. Okay, so whenever there is the excess of air into your engine, so what will happen, it will lead to the complete combustion. So this is the part of the air system. So air injection manifold, that that I made in the pink box. Then the catalytic converter. Okay, so this is nothing but whenever you have the exhaust gas. So for example, in that exhaust gas, you have hydrocarbon, you have carbon monoxide, you have NOx, and this exhaust gas will pass through from some catalyst. And what they will do, this catalyst will provide oxygen to them, will provide the environment in such a way that uh, these hydrocarbons or this carbon monoxide can be converted into water, uh, carbon dioxide, and N2, that is nitrogen, based on some chemicals. Okay, or based on some catalyst. Okay, the next question is the name of the widely used catalyst in catalytic converter are. Can you give me the name of that catalyst that we do use in the catalytic converter? Okay, Nishan gave me answer A. Alka, can you guess the name of the element that we use as a catalyst in the catalytic converter? Rashmi gave me answer A. Mohammed, A or C? Okay. Go with the answer that most of the students gave already. Then you will have the correct answer. Yes, it is A. That is the platinum and palladium. So we do use platinum and palladium as the catalyst in the catalytic converter. We talked about catalytic converter, right? Okay, so we have some methods. So we talked about the mobile sources and how we can reduce the emission from that. Uh, Instead of that mobile sources, or we have the area source. For example, from the agricultural area, we are having the pollution. So how we can reduce it? So to control the dust and particulate matter from your area source, you have to maintain a soil surface cover. Okay, so you have to cover your soil so that erosion can't happen, and because of erosion, there may be the dust problem, right? Then the wind barriers, you can have the vegetation or some artificial barrier by which you can reduce the wind at the surface, and because of that you can control the dust particle. And in that surface, sorry, in that area sources also, there is a crop residue burning problem. You people know about the stubble burning in Haryana and Punjab, and because of that, there is a high air pollution in Delhi as well in the winter time. So how we can control that? So we can compost the residue. We can create the manure, for example. Instead of using the fertilizer, we can use the manure, and that manure can be produced from that residue. Then the production of biochar. This biochar is, I think, some burning material, but I don't know about this. You people can search about this. And the third is mechanical devices. For example, happy seeder. So I already talked about this. Happy seeder is a device by which we can uh, extract out the stubble, and we can grow it at the somewhere else. Okay, because with the help of this happy seeder. So these are the methods that we can apply in the area sources to control the pollutant. Okay, if we want to control the gas, we talked about the particulate matter right now. And if we want to control the gas from the stationary and the mobile sources, then we can do the absorption, we can do the adsorption, incineration, and the carbon sequestration. We will talk about that. Uh, okay, the next question is, dash are usually used to control flammable or exploitive dust or mist from sources. So you have to tell me the right answer for that. What kind of device we use to control this flammable or exploitive dust or mist from the source? Read the answer. Read the question. Yes, Nishant. I told you, like, yes. You corrected yourself. Yes, so answer should be A only. And why A? Because you know that whenever we are using some kind of cloth or the fiber to control your particulate matter, whenever your gas have the high temperature, or your gas may have the corrosive property that can give you the flame in your filters, in your fiber filter. So this is not good to use the fiber filter whenever you have the flammable dust. Okay, whenever there is a flammable dust, means it can corrode corrode or the erode your system. So settling chamber is not for this flammable, because uh, uh, the uniform velocity also taken into consideration in the settling chamber, and if it is a flammable and the exploitive, then it is very difficult to control the speed of your dust. Then the cyclone collector, again this is not the right answer because it will erode the cyclone collector itself. Then the wet scrubber, because we are using the water in the wet scrubber, or some chemicals, the liquid chemicals, and because of that liquid chemical we can control this flammable or the explosive dust or mist. Okay, so the next exercise is based on, like, we will talk about the mechanism and the controlling devices by which we can remove the particulate matters. Okay, so based on some mechanism, we have the controlling devices. So what are these mechanisms we have and what kind of controlling devices we have? So we will talk about this only. Okay, so this is about the mechanism. So which is not the particulate pollutant removal mechanism. So the answer is like out of it, direct interception, inertial deposition, Brownian diffusion, electrostatic attraction, all of the following, none of the above. Question is tricky with the tagline no, which is not the particulate pollutant removal mechanism. So if you want to remove the particulate pollutant, there are some mechanism by which we can remove the particulate pollutant. You people are changing your answer very rapidly. Okay, so what do you think? Answer should be F or not? None of the above, because all of these, what we talked about, are the mechanism by which we can remove this particulate pollutant. Are you satisfied that answer should be F? Okay, so we will talk about this. A note, direct interception is also one mechanism by which we can control the particulate pollutant. These all are the mechanism by which we can control this pollutant. And the answer is not. So because all of these mechanism we people are using to control this particulate pollutant, so answer should be the none of the above, because we are using all of these mechanism. We will talk about this. What do you mean by these kind of mechanisms? Okay, so we have the gravitational settling, centrifugal impaction, then direct interception, electrostatic attraction, inertial deposition, and the Brownian diffusion. These are 6 mechanisms that we use to control the particulate pollution. So let's talk about this mechanism. Why the answer is right. So I don't think right now this is okay. So gravitational settling. So what will happen whenever you have the particulate matter that have the larger size and the heavier mass, that will settle down. Okay, so whenever you have some device in which you give some environment in which the particulate matter can be settled down. So yes, gravitational settling is the one of the mechanism. Okay, then where the particles settle under gravity. The second is centrifugal impaction. What we can do is we can move our gas in the circular pattern. So whenever we are changing the direction of the gas, and gas have the particulate matter, okay, and you people know that gas can very easily can move the direction, right? It can move in the circular path, but the particulate matter that we have in that gas, that will go tangentially in some direction, at the tangent direction, and this is nothing but because of the inertia. Okay, because particulate matter can't move in the circular direction. So whenever so what will happen, because of the centrifugal force, this pollutant or the particulate pollutant, right now we are talking about only the particulate pollutant. Okay, this particular pollutant will go out tangentially from that circular motion, and we can okay, then this is the centrifugal impaction. The third is direct impaction. For example, we have some barrier. So I have hand, and whenever the wind is coming, means wind have the gas and the particulate matter, the gas will go out in the side of it. Okay, because it can change the direction very rapidly, but the particulate matter has very less inertia, sorry, high inertia. Because of that, this will go straight to this barrier. And what will happen? Gas is changing the direction, a particular is not particulate matter is not changing the direction, and it is just getting attached to the barrier. Okay, because this is the direct interception. And whenever we have the fiber filters, okay, we have the cloth filter, what will happen? Whenever the gas will interact with it, the gas will move somewhere else, but the particulate matter will be absorbed into it because of the direct interception. Okay, so we are using that mechanism to remove the particulate matter. Then electrostatic attraction. So this kind of thing we are using, we can charge our particle. For example, we have some chamber. In that chamber there is a high potential voltage. Okay, and what will happen whenever we are charging our particle? Let's say we are negatively charging our particle, and we have some electrode that is positive in charge, so they can neutralize it. The particle can be neutralized it because of the attraction, and it will settle down after getting neutralized. Okay, so this is the electrostatic attraction, we can use that. Then the inertial deposition, this is just like that. Whenever we are changing the direction of the gas, particulate matter can't change very rapidly the direction. It will strike to your barrier, and because of that there will be the inertial deposition. Then the Brownian diffusion. You know that air can move streamline, but the movement of our dust or the particulate matter is zigzag. And because of zigzag, again, wherever there is the obstacle, it will strike to the obstacle straight. Okay, it can. So these are the mechanism by which we can remove our particulate matter, and that's why because that's why these six are the mechanism by which we can remove the particulate matter, and that's why answer was F. Because this all, either it is direct interception, inertial, or the Brownian diffusion, electrostatic attractions, these all are the mechanism that we use to control the particulate pollutants. Okay, the next answer is question is, select the device used to control the particulate matter at the stationary source. So we talked about the mechanism. Based on that mechanism, we do devise some devices. Okay, so you have to tell me the device name that we are using to control the particulate matter at the stationary source. Rashmi and Alka gave me answer C. Yes, yes, I want to ask from Alka and Rashmi, why not B? Can we use the scrubbers? So the answer is B. This is scrubbers, and packed towers are mostly used for the gaseous pollutant. And because we are talking about the particulate matter, then this is the scrubber. So this is the list of the device that we use to control the particulate matter from the stationary source. So we do use the settling chamber based on that gravitational settling. We do use the inertial separator based on the inertial interception. We do use the cyclones. So this cyclone is based on the centrifugal force. As we talked about this, we do use the scrubbers. This is based on the absorption and adsorption. Then we do use the ESP, that is the electrostatic precipitator, by which we can charge our particle. Then we can use the fabric filter, and this fiber filter may have different mechanism from like direct interception to Brownian diffusion to everything. Okay, so these are the devices that we use to control the particulate matter from stationary source based on the mechanism that we talked about, right? So I have MCQs based on these each devices right now. Okay. Uh, I think this question is already we people know. This is right now not important. Okay. So what is true about the settling chamber? So right now we are talking about the devices that we use for to control the particulate matter. Ma'am, but both packed towers and scrubbers are from stationery. Let me see. Have I missed something or not? Uh, Packed towers. We will talk about this, Alka, in the next slide. How these packed towers are not for the particulate matter, but these are for the gaseous pollutants. Oh, I gave you the answer already. So can you tell me the true answer about this settling chamber? Settling chamber, we use the mechanism gravitational settling. Based on that, we have the device settling chamber. So can you tell me the right answer for that? What are the correct statement? The gas velocity must be sufficiently high. The gas velocity must be sufficiently low. We have to minimize the turbulence and ensure uniform velocity, or we have to maximize turbulence and ensure uniform velocity. What do you think? What should be the answer? Can you guess something? Like to settle the particulate matter, what should be the conditions? Alka gave me answers D. What should be the right condition by which we can settle out our particulate matter? Everyone is giving me different options. Rasmi, you don't need to feel sorry. This is just the discussion. You can give me the answer as much as you can give. I will not be disturbed for this. D is the correct, I'm sure. Okay, Alka. So if it is the D, then yes, Alka, you are right. That answer is D only. Okay, so see, this is the settling chamber. Okay, whenever there will be the raw gas that have some particulate matter, then and then in that in this chamber, your velocity should be low enough, because whenever it is a higher, then you are not giving the time to settle down. Okay, so velocity should be lower. The first thing, what was the question? Velocity should be low, and again we have to control the turbulence. Whenever there is a turbulence, then particulate matter will be into your chamber, and the particulate matter will be in your clean air itself. Because of that turbulence is nothing but the disturbance in your uh, kind of atmosphere or the environment right now in that device. Okay, so if you have turbulence, then the settling will not be happen. So that's why Alga gave me right answer. So right now I have written something. The gas velocity must be sufficiently low, less than about 3 meter per second, to prevent re-entrainment of the settled particle, and less than 0.5 meter per second for the good result. Okay, and we have to minimize turbulence and ensure uniform velocity, so that for that we can insert some curtains, rod, or the wire mesh screen to ensure the uniform velocity. Then efficiency is improved is if the height to be traveled by the particle is less. So right now we have the height h. So whenever there is a height is less that has to be traveled by the particulate matter, efficiency will be greater. And to remove the height to be traveled, we use some trays or the shelves, and we do incorporate it into the chamber. And the increase in efficiency obtained by the insertion of this tray, we talked about this, and this is directly proportional to the number of trays, how many trays we are inserting, so that we can reduce the height to be traveled by the particles. And here the minimum particle size that can be removed after installation of trays is about 10 micrometer, but this is after the installment of tray. And if we are not installing the trays, then uh, it can be used to remove particulate above 40 micrometer in diameter. You can see that uh, in the criteria pollutant, we talk about 2.5 and 10 micrometer diameter. Okay, and this settling chamber can only remove the particulate that are above 40 micrometer. And above 40 micrometer, these are not that much harmful to us. So we are using this settling chamber just as a pre-device to before using the high efficiency devices. Okay, we will talk about this as well. So this is all about the settling chamber. The second device to control the particulate matter was the inertial separator. So can you tell me the right statement about the inertial separator? So I have four options. Utilize the relatively greater inertia of the dispersoid. Utilize the relatively low inertia of the dispersoid. There is a continuous change of direction of the carrier gas stream. There is a no continuous change of the direction of the carrier gas stream. So can you tell me the right answer? So this is based on the inertia. As I already told you that whenever in the gas you have the particulate matter, uh, uh, your particulate matter has some inertia, and because of that inertia, it will not go in different direction. It will direct strike to your barrier. So based on that mechanism, we are using the inertial separators. Rashmi gave me answer B, that is second and fourth. Alka A. Alka, you are sure? Oh my God. Alka, you are studying very hard. I think you are giving me the sure answers. Okay, so the answer is A, that is first and third. Means we do utilize relatively greater inertia of the disperser side. As I told you, particulate matter have the high inertia as comparison to the gases. And because of that, you know the mean of the inertia, right? Whenever it is going in some direction, or the velocity will not change. Okay, the speed will not change. This is whenever there is something at rest, it will be at rest. If there is something at the motion, it will be at uh, in motion only. And it just resists the acceleration things, it just resists the turbulence. Okay, so whenever there is a particulate matter that have the high inertia, so whenever it is going in that direction, it will go into that direction, it will not move very rapidly. So because of that high inertia of the dispersoid, the first thing, and because we are changing the direction of the carrier gas, we have some obstacles. We just create obstacles so that gas can change the direction, and we know that particulate matter can't change the direction very rapidly, and because of that we can just control our particulate matter. So that's why answer A and answer A is right, that is first and third. Yeah, here we can see that there is some carrier gas, and we have some construction in such a way that we are changing the direction of our gases. Okay, so whenever changing our direction of the gases, particulate matter will go down, and the clean area, because we are changing the direction, so diffracted clean air will be go uh, out of it. Okay, so this is the principle that we use in the inertial separator. And we have different type of separators. For example, we have the buffer type separator. So what we do, we have some buffers that are in a very irregular shape. Okay, here we can see in that figure we have the irregular shape uh, uh, plates, and because of that plates, whenever there is a flow of gas in that plates, this will give you the inertial mechanism. Means your gas will strike to it, it will change the direction, and but particulate matter can't very rapidly, and based on that, uh, your particulate matter will be collected out. Okay, and then how many number of baffles you are using, what is the spacing of that, the configuration, based on that your efficiency will be dependent on. Then it is all, this method is suitable for removing particles larger than 20 micrometer in diameter. Then another, we have the Louvre type separator. This is the second type of separator, and in which we have this baffles, or in such a way that it can reverse the direction of your air. Okay, so whenever there is a change in the direction of the air, uh, the particulate matter will be collected out, and here it is suitable for the particles that are in larger size, that is larger than 30 micrometer in diameter. We have third type, that is the dust trap, in which what we do, we change the air direction by 180-degree, and because of that we can control our particulate matter that has the size greater than 30 micrometers. So we are exploiting the inertial things of the particulate matter in that device to control the particulate matter, right? Okay, the next question is based on the cyclonic separator. So this is the next device that we use. So can you tell me what force acts on the particulate matter in the cyclonic separator? Question was this one. You already have gave me answer, Alka. We were just talking about different type of separators we do use in that in that. Okay, the next question is which force acts on the particulate matter in cyclonic separator? Rashmi gave me answer A. Nishant C. Okay, Rashmi, you are confusing. Are you confusing into centripetal and centrifugal force? Okay. What do you mean by centripetal? Something that will come inside your center. Centrifugal, that force that will lead the something to go out of that circle, or yes. So there are two different things, centripetal and centrifugal. Yes, it is C answer. This is the centrifugal force. As I told you now, when gases are moving into the circular direction, in the circular motion, so in that circular motion, there is a two type of forces that are balancing. The inner forces, that is the centripetal, and the outer forces, that is the centrifugal. Okay, and because of that inertia, uh, your particulate matter will go out tangentially, and this is nothing but the because of the centrifugal force, right? So here is the mechanism. So answer C is right. So this is the cyclonic separator we do use. So if you can see, there is the dusty gas in. So that dusty gas will go in. It will this dusty gas will move in the circular motion, and because of that circular motion, there will be the centrifugal force that will act on the particulate matter. Because of the centrifugal force, your particulate matter will strike to the boundary of your cyclone, this instrument, and because it will strike to that wall of your cyclonic separator, it will go down. So your dust will be collected at the bottom, but it will like initially there will be the outer spiral movement, and when this dust has been go down, the another spiral inward will give you the cleaned gas out. Okay, so here we can see due to the rapid spiraling movement of the gas, the dispersoids are projected outward the wall by the centrifugal force, and then they drop by gravity to the bottom of the body, where they are collected in the storage hopper. So what we are using? We are using the centrifugal force to control our particulate matter, right? So, and based on that, we have the device that is the cyclonic separator. And whenever the particle have the diameter in the order of 10 micrometer, then the efficiency of that cyclonic separator is greater than 90%. But whenever you have diameter that is larger in size, 20 micrometer, then efficiency is 95%. And it can be operated at the temperature as high as 1000 degree Celsius and pressure 500 atmosphere. Okay, and the efficiency can be increased or decreased uh, based on some characteristics feature of the dust itself, and even the that separator dimension. For example, uh, efficiency will increase if there is an increase in the dust particle size. We already know about this. Dust particle density. If the density is higher, then yes, settling will be more. Gas inlet velocity. If it is a higher velocity, then this cyclone can give you the fast and in a very efficient manner to collect this particulate matter. Then the cyclone body length, then the ratio of body diameter to gas outlet tube diameter. But the efficiency will reduce if there is an increase in gas viscosity or density, cyclone diameter, gas outlet diameter, and inlet width, inlet area. Okay, the next question is about the cyclone separator, and you have to tell me what kind of problem we do face when we are using these cyclone separators. So you people know that each device have some advantages and the disadvantages. So cyclone separator has some kind of disadvantage itself. So what kind of disadvantage we are talking about? What it will create, what kind of problems we may face whenever we are using the cyclonic separator to control the particulate matter. Answer D. There is something that I just put out of the words, so you have to pinpoint it, and based on that you can give me the answer. Yes, C is the answer, because disposal is not the problem. Because you have the particulate matter that is directly settling down, and disposal is not the problem. Disposal is the problem when you are using the wet scrubbers, because you have the water, or you have some chemicals in which you are dissolving your particulate matter or the gas. Okay, and that will give you very sticky, and you have to do the sewage treatment of it. Okay, then that is the problem with wet scrubber, but disposal is not the problem with cyclone, but the erosion. Whenever your gas have because we know that a cyclone works in like efficiency is greater when the velocity of your gas is very high. And if the gas is very high, the velocity is very high, then there may be the erosion. Okay, erosion of your cyclone itself. Then whenever your gas have the corroded property, then it can lead to the corrosion. And the third is material buildup. This is like the dust can be deposited on your cyclone itself, cyclonic separator itself. That is like the we call it as a dust cake. Okay, so cake can be created in your cyclonic separator itself. So you have to either insert some rim, or you must have some method by which you can remove that dust cake out of this cyclonic separator. So erosion, corrosion, and material buildup are the problem with the cyclone, no, but not the disposal. And based on that, your answer C should be right. Okay, the next device is fabric filter. So the efficiency of fabric filter of the size range of 0.1 micrometer to 1000 micrometer is close to. So you have to tell me the efficiency of the fabric filter when the size of your particulate matter is ranging from zero point 0.1 to 1000 micrometer. Can you guess something? What should be the efficiency of fabric filter? Nishan gave me answer D. Alka also gave me answer D. Rashmi C. The collection efficiency is closer to 99%. Like out of all the devices, whatever we talked about, efficiency of fabric filter is so high, and that is 99%. But there are some problem with fabric filter. We will talk about it. That's why we do not use the fabric filter, but the efficiency is so high. Anyway, so the efficiency is 99. Yes, Rashmi, clogging is the problem, and more than it, like when the temperature of your gas is so high, from, for example, from the industries, gas may have the high temperature, then there may be the flame because of that high temperature. If your gas have the corrosive property, then it can do the corrosion. uh, Another is uh, it may be the particulate matter have some the shape, that shape can tear out your fabric as well. So there are lots of problem with the fabric filter, but the thing is that efficiency is so high, that is 99%. Why zero point 0.1 to 1000 included in a single range? uh, Here this like I can also set this question like that as well, ki the collection efficiency of fabric filter of the size more than or the larger than zero point 0.1 micrometer is close to. It means the basic idea is that it can remove the particulate matter that have the size greater than zero point 0.1, and the efficiency is 99. Okay, so here in the fabric filter, the flue gas is passed through a tightly woven or the felt fabric, causing particulate in the flue gases to be collected on the fiber by sieving or by some other mechanism. And here we do use the ratio, that is air to cloth. How much air flow we have in that filter and how much surface area we have of that fabric itself. Okay, based on that, uh, it is very important to calculate this ratio, because we must have the ratio where the cloth area should be higher. Only then the efficiency will be increased. Okay, so this is the fabric filter baghouse. You can see we have a lot of fabric filters, like thousands of fabric filter within one device. And because of that, uh, here from the down, there is a dusty air inlet. And whenever it will be in contact with the fabric filter, this fabric filter uh, will collect this particulate matter in itself. Okay, and then there will be the clean air outlet out of this baghouse. So likewise, like we have different type of fabric filters. Okay, the particle collection mechanism in the fabric filter are, so we talked about the mechanism, right? And what kind of mechanism the fabric filter uses? So can you tell me? Impaction, Brownian diffusion, electrostatic attraction, absorption. I show you the picture of this fabric bag, so you can guess what kind of mechanism it can use to collect the particulate matter. And we talked about each mechanism. Uh, B, C, A, everyone is getting confused. But you can just see how why the efficiency of your fabric filter is so high. There may be some reason, there may be various of mechanism that can be exploited. Which is the answer. Okay, so C answer is the right. That is first, second, and third. Absorption is not the right answer right now, because absorption, whenever we are talking about the absorption, then this is just we are using some liquid. In that liquid, we are absorbing uh, some gas, some gases or the particulate matter. So that's why A, first and second and third. We will talk about this electrostatic attraction itself, because we have some fabric filters that can use the electrostatic, as we talked about the van der Waals force. There may be like some physical contact that may be happened. Okay, here we can see the inertial impaction. So this barrier is, let's say, the filter fabric. Okay, and here we have the gas that are changing the direction, and here the black dot are the particulate matter. So, and this barrier is fabric. So this can give you the inertial impaction, this can give you the Brownian diffusion, and this barrier can also give you the electrostatic impaction. Okay, then that's why the answer was this first, second, and third. That is the electrostatic attraction is also one of the answer. Okay, what filter ratio will increase the efficiency of fabric filter? So we have a ratio that is known as the filter ratio, and when the efficiency of the fabric filter will increase with respect to this filter ratio. First, you people should know what do you mean by this filter ratio, and then what should be the value of it. Come on, guys. We are just talking about the stationary source and only the particulate matter. Then we have to move on this gaseous pollutant itself. Okay, no one know about this filter ratio. That's why no one is able to give me the answer. But anyway, okay, Rashmi gave me answer B somehow. Answer is A, that is low filter ratio, and uh, there is a definition, like filter ratio is defined as the ratio of the carrier gas volume. Okay, so volume of the gas to the gross filter area per unit flow of the gas. Okay, so your volume of carrier gas should be low as comparison to the filter area. So that's why whenever there is a low filter ratio, then this will give you the efficiency. So excessive filter ratio lowers particulate removal efficiency and result in increased bag tear. Therefore, low filter ratios are recommended for high concentration of particulates. So you people know about right now the what do you mean by the filter ratio? Okay, as I told you that efficiency is 99%, but we have some disadvantage as well. And these advantages are because we are using some fabric, and this fabric may or may not be acidic resistance, may or may not be the basic resistance, because we know that gas can be acidic in nature, gas may be the basic in nature, gas may have the high velocity. So there must be some properties, like your fabric must be acid resistance, your fabric must be alkali resistance, the tensile strength should be higher there, like there should not be abrasion because of the velocity every time the gas is striking to the fabric. So here we have some fabric: cotton, wool, nylon, dacron, polypropylene, and the fiberglass, and each of these have and even like how much temperature they can tolerate. So we have uh, different values for different fabrics, and based on our need, for example, if the pollutant that is being released from your industry is very acidic in nature, okay, then it is better to use the polypropylene. Okay, but if the temperature of your gas is very high, then it may be better to use this fiberglass. So based on the physical properties of the fabric, you can decide what kind of fabric you need in that your bag house. Okay, there are some disadvantages of filter as we talked about this. Because of high temperature of the carrier gas, high humidity and another parameter, high maintenance is required, large size of equipment it is, then it also requires dry environment, otherwise that clogging problem will be there. Then there may be fire or explosion potential, and there may be problem in handling dust that may abrade, corrode or the clog the floor. Okay, so the next question is based on some another device, and you have to tell me the device. So, in which device gas stream is passed between two electrodes across which a high potential difference is maintained? So, what kind of devices I'm talking about? Ah, Rashmi is so quick to give me the answer. That B. Okay. Abdul also gave me answer B. Alka, what do you think? What should be the answer? Nishant? Okay, so everyone gave me answer B. So yes, answer is B. That is the electrostatic precipitator. So here it is. You can see we have some plates. Okay, and these plates are connected to uh, the voltage potential, and because of that, it will have some charge. Okay, uh, whenever a gas is coming in that plate, so the gas will contain the negative charge. Okay, and because your plate have the positive charge, your gas will be attracted to the positive charged metal plate, and because of the neutralization, your particulate matter will be collected out. Okay, so this is the mechanism how we can use the electrostatic precipitator. Such kind of precipitator we have in reality, and at the end of it there is the collecting plate, and this is the mechanism. Okay, so the working of ESP, that is the electrostatic precipitator. So the gas stream is passed between two electrodes which have the high potential difference, and one is the discharging electrode and the second is collecting electrode. So one may have the positive charge and another will have the negative charge. Then because of the high potential difference and discharge system, a powerful ionizing field is formed. And because of that ionization, whatever the particulate matter you are having, that will also contain that charge. Okay, and that will migrate to the positive charge collecting electrode, and it will get deposited and it will lose their charge, and this how we can uh, collect the particulate matter, and here the efficiency is greater than 99%. uh, this is very good and very sensitive a device. Okay, then control device that can be used to collect both particle and gas is. So up to now we talked about the particulate matter, right? And these devices, all devices were focused on the particulate matter only. But there is one device that can be used to control both the particles and the gas pollutant. Alka gave me answer A. Come on, guys, we already have talked about some devices, and that devices were dedicated for the particulate matter only. So what's the remaining device? We talked about fabric filter, we talked about the cyclone separator, we talked about the ESP, and these were dedicated to the particulate matter only. And the next is wet scrubber, because and this wet scrubber can be used for both particles and the gas. Okay, so here is the wet scrubber. So in that we have the spray tower by which we can spray the water, for example, and whenever there is a spray of this water, so what will happen? Either it is a gas or the particulate matter that can be collected at the bottom. Okay, and we can use limestone, gypsum to maintain the pH of our gas or the sewage or the sludge we will get after that, and the clean air will go out from the top of it. So this is the wet air scrubber. Okay, so wet here particulates are removed from the gas stream by one or the combination of the following mechanism. So again, here we have different type of mechanisms by which this wet scrubber works. So for example, Brownian diffusion, we already talked about this. Inertial impaction, the direct interception, we talked about this. Then the electroscavenging. So what do you mean by this electroscavenging? This is nothing but we talked about this. Now we are spraying some kind of chemical or the liquid chemical. Okay, then whenever there is a charge at that liquid chemical or the liquid spray that we will have, then that charge can give you different kind of controlling characteristics. So this is the electroscavenging when your liquid droplet has some charge. Then the phoresis is nothing but whenever we are increasing or decreasing the temperature of a droplet. Okay, and whenever we are doing this, because of that, like there may be some condensation. Because of that, the like there may be some kind of gradient. Okay, and because of that gradient, absorption or the collection of the particulate matter as well as the gases can be happen. So this is the phoresis. And we do have different type of wet scrubbers. For example, spray tower, venturi scrubber, cyclone scrubber, packed scrubber, and the mechanical scrubber. And Alka, yes, we do have this packed or venturi scrubber, and this both can be used for both particulate matter and the gaseous things. Okay, so up to now we just talked about the particulate matter because this was the important, and now we will talk what different kind of mechanism and based on the mechanism, what different type of control devices we have to control the gas. For example, if we have the carbon monoxide, for example, if we have the ammonia, for example, if we have the hydrocarbons, so and these are emitting from the industries, so how we can control that, what kind of devices we have and what kind of mechanism we can exploit. So we have the techniques we can do adsorption, we can do the absorption, we can use the biofiltration, oxidation and the condensation. So these are the techniques we can exploit to control our gaseous pollutant. So these are the mechanism. This is again the question. I don't know how many time it will come. Which device is not used to control the gaseous pollutant at the stationary sources? Some gave me answer C and some may gave me answer D. Uh, we are talking about right now the gaseous pollutant, and you can guess. We talked about the particulate matters and the devices associated with it. Nishan, did you change your answer? Okay. Uh, of course, answer should be C, fabric filter. We talked about it, that fabric filter can only use for the particulate matter, but the packed tower, venturi scrubbers, use of some adsorbent, and we can use the combustion or the incineration for the hydrocarbons. So for the gas that have the hydrocarbons, that for that we do use the combustion and the incineration equipment. So fabric filter, we talked about that, no? Okay, so these are different devices that we can use to control the gas from the stationary sources. Okay, which chemical is not used as the gas adsorbent? So if we want to adsorb the gas, means we have some surface, and whenever gas will contact to it, so gas will be attached to it. But in the previous question, wet scrubber is a device, not pollutant. Where? I didn't understand your query, Alka. I didn't understand. You can tell me what do you want to say. Here, can you guess which chemical is not used as the gas absorbent? As I told you, we have some surface, and on that surface, gas will be attached to it. And if it is attached on the surface only, it is not going to be absorbed, and this is the adsorption. And we have some chemical by which we can absorb the gas on the surface areas, on the surface. So you have to tell me which chemical we are not using as a gas absorbent. Yes, answer is chlorine gel, because this is not the chlorine gel. There should be the silica gel, because we do use the silica gel for the gas adsorption. Okay, so the type of adsorbent we had is activated carbon. And here, because the surface area is very important, because on that surface only there gas will be attached to. Okay, so whenever there is a high surface area, then there will be higher efficiency of the adsorption, right? So yeah, here you can see that the activated carbon has a very good surface area, that is 600 to 1600 meters square per gram. Then we have the zeolite, we have the synthetic polymers, we have the silica gel, and we have the activated alumina. So these are different absorbent that we can use to adsorb the gas. Okay, mechanism of the absorption is governed by which law? Yes, Rashmi, you can leave. Thank you so much. So we talked about adsorption, but this is absorption. So absorption is governed by which law? There is a difference between adsorption and absorption. As I told you, for the adsorption, there is some surface. That surface be solid in nature, and on that surface, gaseous pollutant will be attached to. So that is the adsorption. But here the question is absorption. So absorption is, we have some liquids. In that liquid, the gas will be dissolved. Okay, so gas dissolve in the liquid. So here, this is based on what law? Nishant came and said B. This is, I think, ninth class or 11th class content. That partial pressure of the gas that will be dissolved in the liquid is directly proportional to some constant and the concentration. So which law we are talking about? Yes, this is Henry law. So Henry law is just nothing but the concentration of your gaseous particle that will be absorbed in the liquid is directly proportional to the partial pressure of your gas is directly proportional to the concentration of your liquid. And whenever we are equating it, then there is a Henry constant. So you people can read about this. But right now, if there is a liquid and the gas, and there is kind of absorption, then there is the law, that is Henry law. Okay, the process of collection of the contaminants on the surface of a medium that contain viable microorganism is known as. So this is different mechanism that we. No, no, Nishant, this is not the bioscavenging. So instead of activated activated carbon, we use the surface of the microorganism so that that microorganism can take your gaseous pollutant and based on the metabolism, that gaseous pollutant can be converted into simpler gases. So we have some microorganism that will take, for example, carbon monoxide, for example, hydrocarbons, because these hydrocarbons can be the food for the microorganism, and this microorganism then with the metabolism, with the digestion, will give you the water and carbon dioxide only. Okay, let me see the answer who gave me what. Nishant changed to A now. Mohammed is still at B, and Alka gave me answer A. Then this technology is the biofiltration. Yes, so answer should be A. This is the biofiltration only. Okay, so I think I have one or two question more. I'm just completing it. So this is different technology that we use to control the gas compound. Here, for example, we have the hydrocarbons. This hydrocarbon uh, will be destroyed, and this mechanism destroy organic compound in the effluent gas stream. Therefore, they are used when the economic recovery of the compound is impractical. Can you give me the answer for that? You can canceling out the devices that we already have talked about. Okay, Alka gave me answer A. Okay, Abdul is also saying that A, I guess. Okay, your guess may be correct. Okay, so answer is A only, that is the oxidation system. So we are providing the oxygen. Okay, so for example, if we have some organic compound means most of the hydrocarbon compound. So if we are giving the oxygen to the hydrocarbon, then this will be converted into water and carbon dioxide. Okay, but we have to keep in mind that it may be that some of the organic compound may be important for us. Okay, it may be expensive, so whether we can recover it or not. If we can recover it, then oxidation system is not good because it is just destroying your organic compound. Okay, but if you want to recover it, then we have different mechanism for that. So oxidation system is such a system by which we can destroy the organic compounds in the gas. So A is the right answer. Okay, so the here you can guess. In that mechanism, we do recover the organic compound present at moderate to high concentration in industrial process effluent gas stream. So if you have hydrocarbon in your gas, you can recover it by some method, and you can, and by which you can also avoid the release of that hydrocarbon into the atmosphere. So what is the technology we are talking about? Can you guess? In previous year assignment as well, there was some this kind of question we had, and Alka, you gave me right answer for that. Okay, now you gave me B. Condensation system. Yes. So what we will do whenever the gas that have the hydrocarbon that are releasing, so we will reduce the temperature of that tube from which the gas having the hydrocarbon is releasing. So after reducing the temperature, what will happen? Condensation will happen, and because of that condensation, your hydrocarbon will be as it is will be collected inside your industry itself. Okay. Yes, Nishan, this is B. That is the condensation system. Okay, so that was all about the different mechanisms and the devices we do use for controlling the air pollution.